Okay, let's dive into this. We talk about dimensions all the time, right? 3D movies, 2D drawings. But what does that word really mean? Well, we're about to unpack the whole thing, from the simplest line you can possibly imagine, all the way to these tiny, hidden, curled-up dimensions that might just be the secret ingredient of our universe.
So let's start with the most basic question of all. What is a dimension? Now, on one level, the answer is actually pretty simple. But where that simple answer takes us, well, that's where things get really interesting.
You see, at its heart, a dimension is just a coordinate. It's a piece of information you need to find something. Think about it like you're giving directions. If I just say, meet me on the street, that's not enough, is it? You need to know how far along the street. That's one coordinate, one piece of information. So the number of independent measurements you need to pinpoint an exact location, that number, that's its dimension.
All right, so before we jump into the deep end with some of the more mind-bending stuff, let's start right here at home. Let's ground ourselves in the dimensions we all know and experience every single day. 1, 2, and 3D.
First up, one dimension. Picture a tightrope walker balancing on a wire. To know exactly where they are, you only need one piece of info, right? How far they've moved from the starting point. That's a one-dimensional world. It's just a line, and any point on it can be found with a single number. Simple.
Now, let's add another dimension. Let's go to 2D. Imagine a totally flat sheet of paper. To find a single dot on that paper, you now need two numbers, how far over and how far up, an X and a Y coordinate. It's exactly like a map. You need both latitude and longitude to pinpoint a location on the Earth's surface. That's a 2D space.
And then there's our world, the world we live in, the space we move through. It's three-dimensional. To locate absolutely anything, whether it's a plane in the sky or your keys on the table, you need three coordinates: length, width, and height. Or, left and right, forward and backward, and up and down. This is our reality.
Okay, you with me? We've got 1D, 2D, and 3D down. Now we're going to try something that sounds, well, impossible. We're going to try and visualize a fourth spatial dimension. And believe it or not, there's a surprisingly simple, logical way to wrap our heads around it.
Just look at the pattern. It's beautiful. You start with a point which has 0 dimensions, drag it through space, and it leaves a trail, a one-dimensional line. Now take that entire line and drag it in a brand new direction, one that's perpendicular to it. What do you get? A two-dimensional square. You see where this is going, right? Drag that whole square in a new third perpendicular direction, and poof, you've got a three-dimensional cube. The logic is solid. So what's the next step? We just follow the pattern. We take our 3D cube and drag it through a fourth spatial dimension, perpendicular to all the others. And the shape that it traces, that's a tesseract.
And this visual just lays it all out perfectly, doesn't it? From a simple point all the way up to this complex, shifting shape of the tesseract. And think about it this way. A cube is a 3D object made up of 2D squares, right? Well, following that same exact logic, a 4D tesseract is made up of 3D cubes. What we're seeing here is really just the shadow of a four-dimensional object projected into our world. The key takeaway is this, and it's so cool. A tesseract is to a cube what a cube is to a square.
Okay, so right about now, a lot of you are probably thinking, wait a minute, I've always heard that time is the fourth dimension. That's a super common idea, but it can also be pretty confusing. Are we talking about the same thing as this tesseract? The short answer is no, not at all. And it's a really, really important distinction to make.
So let's clear this up, because it's a big deal. When people say the fourth dimension, they could be talking about two totally different concepts. On one hand, you have the fourth spatial dimension. That's the theoretical direction, another up or left, that we use to mathematically build the tesseract. But in physics, when scientists talk about the fourth dimension, they almost always mean time. Thanks to Einstein, we know our universe is this four-dimensional fabric called spacetime, woven together from the 3 dimensions of space we know and 1 dimension of time.
So, okay, 3 dimensions of space, 1 of time, 4 in total. That's our universe, we're done, right? Ha, not even close. Just when you think you've got a handle on it, modern physics shows up and says, actually, we're going to need more. A lot more. It turns out that some of our most promising theories about how the universe actually works, they just completely fall apart in only 4 dimensions.
Get this. Take superstring theory. This is one of our best shots at creating a theory of everything, right? A single, elegant framework that explains all the forces of nature. There's just one little catch. For the math to work, for the theory to be consistent at all, the universe can't have 4 dimensions. It has to have 10. That's 9 dimensions of space and 1 of time.
And if you thought 10 was wild, it doesn't even stop there. Another, even more encompassing idea called M-theory, which is trying to unite all the different versions of string theory, goes one step further. It, along with another theory called supergravity, suggests that reality might actually be playing out across 11 dimensions.
So, this of course leads to a very, very obvious question. If there are 6 or 7 extra dimensions of space all around us, right here, right now, where are they? Why can't we see them? Why can't I just, point in a new direction and step into one?
Well, the leading theory is this absolutely fascinating idea called compactification. The thought is that these extra dimensions are, well, they're curled up on themselves. They're rolled into a shape so unbelievably tiny, way, way smaller than a single atom, that we just can't see them or interact with them. It means that every single point in the space around you could actually be a little gateway to one of these intricate 6-dimensional shapes, like the Calabi manifold you're seeing here.
I know, this all sounds incredibly abstract, maybe even like science fiction. So you're probably wondering, why bother? Why are scientists dedicating their lives to this stuff? Well, the thing is, these extra dimensions aren't just a mathematical party trick. They might actually be the key to solving some of the deepest, most fundamental mysteries of our entire universe.
So why chase these hidden dimensions? Well, for one, they could be the missing piece of the puzzle for unified theory, a single explanation for all of nature's forces. They might also solve a giant mystery. Why is gravity so ridiculously weak compared to, say, magnetism? One idea is that gravity is the only force that can leak out into these extra dimensions, so its strength gets diluted in our world. And at the end of the day, these theories aren't just a fun idea. They might be telling us what the fundamental geometry of reality itself actually looks like.
So look, if you take just one thing away from all of this, let it be this. Dimensions are just the coordinates of reality. They're the address you need to find any event anywhere in the universe. And it is completely possible, even likely, that the universe's address book has way more coordinates in it than our senses are equipped to perceive. And it's so important to remember, this isn't just about weird physics. The concept of dimensions is a powerful tool everywhere. A data scientist at a tech company might be working with a data set that has hundreds of dimensions to find patterns we could never see. An economist might model a market using dozens of variables, or dimensions. It's a fundamental concept for making sense of any complex system.
Which leaves us with one last, pretty mind-blowing thought to chew on. We've gone from a simple, one-dimensional line all the way to a universe that might be woven out of 10 or even 11 dimensions, with most of them completely hidden from us. And it just makes you wonder, if reality is already this much more complex than it appears on the surface, what else are we not seeing?